is distribution of electron in the orbital. So as we discussed earlier, that is this distribution of electron in d orbital will be depend upon the type of ligand actually. So whenever there is a strong field ligand, then the pairing will be take place, and then there is a weak field ligand, then it does not pair. So before that there are some criteria to filling the electron in respective orbital. First rules is that the electron will occupy the lowest energy first. First it will be going to lower, then after that fulfillment of this lower energy level, it will be goes into upper energy level. Hund's rule of maximum multiplicity will be followed. Pairing of electron does not occur until all the degenerate orbitals are singly occupied. Here there will be third, that is this condition, that is delta 0 P. Here this P is a pairing energy. So what is pairing energy? First we are discussing the pairing energy. So here pairing energy means the energy required to pair the electron. So pairing energy is nothing but the energy required to pair electron. Then fourth, that is so for that condition actually we will discuss it first. So this is a splitting factor or splitting parameter which is greater than the pairing energy, means that pairing energy is small, means that the ligand is a strong field ligand, so that's why there will be not needed to pair the electron. Automatically when there will be the strong field ligand, the electron pairing will be take place. So here the ligand is strong field. Then the next one, that is the next condition, that is fourth, that is in that condition pairing energy is higher than the splitting parameter, means that the ligand is weak field, so it will require the energy to pair the electron. So the pairing energy here, pairing energy is greater. Then splitting factor. So these are the general rules which is followed for the distribution of electron in d orbital. So related with this 2 or 4 rule, related with this 2 concept, there will be the new concept that is, so related with these two concepts, there will be again two concepts, that is a high spin complexes and low spin complexes. Let's see what is meant by the high spin and low spin complexes. We will discuss this high spin and low spin complexes by taking the example, the electron which is present in, that is d4 configuration in octahedral field. So here, that is, so there will be the here, that is 4 electrons. So we can electrons 1, 2, 3, 4. Here that is an energy. This is an Eg. This is T2G orbital. So for D4 we are entering 1, 2, 3 according to Hunt. So the electron, firstly the electrons goes into lower energy. According to Hund's rule, it will be singly occupied, and whenever it will be singly occupied, after that the pairing will be take place. So here 1, 2, 3, and there will be one electron is remaining. So that is a 4. This is a for strong field, because here, that is, pairing will be done. It will not goes into Eg orbital directly. It will be here, that is for weak field. So again there will be 1, 2, 3. This is Eg. This is T2G orbital here. That is 4 electron we have to put up in respect to T2G and Eg orbital. So here 1, 2, 3. Here pairing will be not possible because this is a weak field ligand. So it will be not enter into again for pairing in this orbital. It will be directly goes into Eg orbital because the ligand is weak field. So pairing will be not possible. So this is a weak field ligand, and this is nothing but the, as we know that this is a 10 dq value for this Barry center. So this is a 6 dq. This is so this is total, that is a 10 dq. So this is a strong field and this is a weak field, and the D4 for D4 configuration in octahedral field. So here from that we can observe that how many unpaired, we can compare this 2 electron, sorry, for the low spin. What, so now the question is that what is a low spin and high spin? So the low spin are nothing but there will be the minimum number of unpaired electron. If you count here, that is the number of unpaired electron, that is 2. So here we can write unpaired electron is 2, and here the unpaired electron is 1, 2, 3 and 4. So the unpaired electron for weak field is more. So here from that we can say that the complexes which is formed by strong ligand have a minimum number of unpaired electron are known as a low spin complexes. So the complexes are formed by, we can write here that the complexes formed by strong field ligand have a minimum number of unpaired electron the complexes formed by weak field ligand have a maximum number of unpaired electron is has spin complex. So this is known as a low spin and high spin complexes. So there are be various orbitals, that is d1, d2, d3, d4, d5, d6, d7, d8 and d10 orbital. So this d1 to d10 orbital, there will be distribution of electron in strong field and weak field complexes are different. So we will discuss it. So if you observe here, that is the system, that is d1, d2, d3, d4, d5, d6, d7, d8, d9 and d10, and d-electrons in T2G and Eg orbital in strong octahedral field. So let's discuss how the electron are distributed in T2G and Eg orbital. Let's discuss. So for d1, that it will be good. So here there will be different system, that is d1, d2, d3, d4, d5, d6, d7, d8, d9, d10. Now for T2G there will be 3, as we know that there will be 3 orbitals, so we can write these 3 orbitals first. 1, 2, 3, 1, 2, 3. And for Eg there will be 2 orbitals, so we can write it. The respective electron into that orbital. So for d1 there will be 1 single electron, for d2 there will be 2 electron, for d3 there will be 1, 2 and 3. For d4, as we know that this is a strong field ligand, so after occupying 1 electron singly, it will be paired into that orbital, because the ligand is our ligand is a strong field ligand. So for d5 again it will be 1, 2, 3, 4 and 5. For d6 1, 2, 3 and again there will be pairing due to strong field ligand. So here that is a 6 electron. For d7 that is 1, 2, 3 and here d7 means that is this is 1, 2, 3 and now pairing, that is 4, 5, 6. Here 1, 2, 3, 4, 5, 6. Our electron is a 7. So 1 electron goes into Eg, isn't it? Now for d8 it will be 1, 2, 3, 4, 5, 6. 2 electrons are remaining and it will be after pairing, it will be shifted into Eg orbital. After in d9, that is 3 electrons are singly paired, then it will be 4, 5, 6, then 7, 8 and 9th electron will be getting for d10 1, 2, 3, 4, 5, 6. 4 electron will be remaining. So here in T2G, for d10 system, in T2G and Eg electron, T2G orbital, the electron will be paired totally. So here what is a N? So N is a number of unpaired electron. So here, and S is also known as a spin, that is spin of electron, and the simple formula of that spin, how to calculate spin, that is N by 2. N means number of unpaired electron, we have to put up the unpaired electron divided by spin. Whatever be the answer, that is a spin of that respective complex. Now let's discuss what is N. For d1 that is 1 because there is a 1 unpaired electron. Here that is a 2 unpaired electron, so the number of unpaired electrons is a 2. For d3 there will be 3 unpaired electrons, so here that is a 3. Here for d4 that is a 1 is a pairing, so just 2 unpaired electron is showing here, so that is a 2. For d5 there will be 2 pairing and 1 unpaired electron, so the number of unpaired electron is 1. Here for d6 there will be no any unpaired electron because all T2G orbitals are paired. So that's why the number of unpaired electron is 0 for d6. And for d7, in T2G there will be all electrons are paired, but still 1 electron is unpaired in Eg. So that's why this is an 1 unpaired electron. In d8 that is electron, means there will be not unpaired electron available in T2G, but EG there will be 2 electrons, so the number of unpaired electron in complexes, that is 2 for DH system, and for D9 the number of unpaired electron here, that is 4 paired, that is 3 paired in T2G, 1 paired in EG, so 1 unpaired electron is showing. And there will be for D10, as we earlier discussed, that is no unpaired electron, all electrons are getting paired, so the number of unpaired electron is a. So here this is a, we get the value of number of unpaired electrons, so from that we can calculate simply the spin. So for D1 system the spin is a, that is for D1 we can say that for D1 that is n by 2. Okay, so for D1 the number of unpaired electron is a 1, so 1 by 2, so the answer is a 1 by 2. For D2 it will be 2 by 2, means it will be 1, so the spin is a 1. For 3 it is a by 3 by 2. For 2 again there will be 1 spin. For 1 that is again 1 by 2. For 0 spin is again 0. For D7 there will be again 1 by 2. For 2 there will be 1, there 1, again 1 by 2, and there is a 0 to 0. Means that from this distribution of electron according to strong field and weak field depending the complexes, that is low spin or high spin. So this is all about the distribution of electron in T2G and EG orbital in strong octahedral field. Now let's discuss what is for weak octahedral field. So we can write simply here, that is for weak octahedral field. So for weak octahedral field, the same system we followed, that is D1 to D system. Here the same again for T2G there will be 3 orbital. And EG there will be 2 orbital. Now we will so again there will be the distribution of the electron in weak field. Now in weak field means that there will be not pairing is possible. The electrons are directly goes into EG. It will be not paired after filling one orbital. After filling one electron each in T2G orbital, it will be not paired, it will be direct goes into EG. So let's discuss. For one that is 1, D1 for that is T2G1, then D2 again for T2G that is a 2. For for D3 there will be the 3 electron, and for D4 that is 1, 2, 3. Here 1 electron is remaining. If here the ligand is octahedral, if the ligand is strong field, then we can put the 4th electron here and this pairing will be possible, but here it is not possible, it directly goes into EG, so pairing is not possible in weak field complexes. Now here 5, that is 1, 2, 3, and 4 and 5th directly goes into EG. Now this for D6, that is 1, 2, 3, 4, 5. After filling electron singly in T2G and EG orbital, the remaining electron will goes into T2G orbital, because here if there is a strong field ligand, the arrangement is like that, the 3 T2G orbital getting paired, but here it is not possible because the ligand is weak, so it will be, first it will occupy the T2G and EG orbital singly, then after that it will be enter into the T2G orbital. Now for D7, that is 1, 2, 3, 4, 5, 6, 7. So here the number of unpaired electron pair is a 2. So here first we have to put up the electron singly in T2G and EG orbital. After that whatever electron will be remaining, it will be goes into the T2G orbital. So here for this 8 system, for D8 this is for D8. For D9 it will be 1, 2, 3, that is 5, 4, 5, 6, 7, 8. 9. The 10, for 10 that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you observe for D10 system, in octahedral, in strong and in weak field, in strong and weak field, the number of unpaired electron will be same. Spin is same, isn't it? So here, now what about the N? Here 1 unpaired electron, here that is 2 unpaired electron, here that is 3 unpaired electron, here that is a 4 unpaired electron, here again there will be the 5 unpaired electron, here that is 6 unpaired electron, here that is 3 unpaired electron for D7 system, and for D8 system it will be 2 unpaired electron. Here for D9 system there will be only 1 unpaired electron, and for D10 there will be 0. So what about their spin? So spin is 1 by 2, 2 by 2 that is 1, 3 by 2, 4 by 2 that is 2, 5 by 2, 6 by 2 that is a 3, 3 by 2, for 2 that is 1, for 1 that is 1 by 2, and again for D10 that is will be 0. So if you observe in octahedral, strong field and weak field, comparison with the strong field and comparison in between the strong field and weak field ligand, the number of unpaired electron is increasing in weak field complexes because the pairing is not possible, so that's why the number of electron will be maximum. So this is the difference between the distribution of electron in T2G EG orbital in strong field and weak field complexes. So we will stop here.